A colossal event is slowly unfolding in the darkness beyond our skies. Right now, our home galaxy, the Milky Way, is drifting toward a direct encounter with its giant neighbor, Andromeda. Two immense islands of stars, each carrying hundreds of billions to trillions of suns, are moving toward one another through intergalactic space like unstoppable cosmic juggernauts. And although it sounds impossibly distant on the timescale of the universe, this collision is surprisingly close. Tonight, we're leaping billions of years into the future to witness one of the greatest spectacles the cosmos will ever produce. The moment two galaxies begin to tear through each other at speeds exceeding 400,000 kilometers per hour. An impact so enormous it will completely reshape the night sky forever. And if a single asteroid was enough to erase the dinosaurs from Earth, what happens when an entire galaxy crashes into ours? To understand what's coming, you first need to realize something strange about your own existence. Even standing perfectly still beneath the stars, you are already moving at incredible speeds. The Earth itself is spinning beneath your feet. Depending on where you live, especially across regions like Europe or North America, you're being carried around the planet at over 1,100 kilometers per hour. Fast enough to rival the speed of sound, yet you never notice it because everything around you is moving with you at exactly the same rate. If the Earth suddenly stopped rotating, the consequences would be catastrophic. The atmosphere, the oceans, buildings, forests, everything not anchored deep into the crust would continue moving, violently thrown eastward at tremendous speed. But Earth's rotation is only the beginning. Our planet is also racing around the sun at roughly 30 kilometers every second. That's close to 100,000 kilometers per hour. Meanwhile, the sun itself, carrying the entire solar system along with it, is orbiting the center of the Milky Way at nearly 720,000 kilometers per hour. So even at this very moment, without feeling a thing, you are hurtling through the galaxy at speeds almost impossible to comprehend. And our galaxy isn't wandering aimlessly. Far beyond the glowing band of the Milky Way lies Andromeda, the nearest major galaxy to our own. Every second, the distance between us shrinks. Gravity is overpowering the expansion of the universe between the two galaxies, pulling them together in a slow but unavoidable descent toward collision. From far away, the scene would look almost unreal. Two gigantic spirals of light turning silently through space, each one stretching across hundreds of thousands of light years, gradually closing in for impact. But this won't be a single explosive crash. The first encounter will send both galaxies ripping through one another. Their shapes will distort. Vast streams of stars and gas will be flung outward into space. Then gravity will pull them back together again and again. Multiple passes, multiple collisions, stretching across billions of years until eventually both galaxies merge into one enormous new galaxy entirely, and the scale of this event is staggering. Andromeda alone contains around 1 trillion stars. The Milky Way contributes hundreds of billions more. Looking at those numbers, it seems inevitable that stars would smash into each other everywhere. A universal chain reaction of destruction. But the universe is stranger than it appears. Quick pause before we continue. If you're enjoying these deep dives into space, mysteries, and the universe, hit like and subscribe. It helps us reach more people. Every single subscription pushes us one step closer, and now, let's get back to it. Even inside galaxies packed with stars, the distances between individual solar systems are so unimaginably vast that direct stellar collisions are actually extremely rare. In many ways, galaxies are more empty space than anything else, which means that during this cosmic merger, most stars, including our sun, may pass through the chaos untouched. But untouched does not mean unchanged. Up close, galaxies are far emptier than they appear. Even though both the Milky Way and Andromeda contain staggering numbers of stars, the distances separating those stars are almost unimaginable. On average, neighboring stars are spaced about 5 light-years apart, roughly 47 trillion kilometers. Even the closest star to our solar system, Proxima Centauri, is still over 4 light-years away. More than 40 trillion kilometers separate us from that tiny point of light in the sky, which means that when galaxies collide, most star systems won't actually smash directly into one another. There's simply too much empty space in between. In most cases, entire solar systems would silently drift past each other without ever making contact. The scale of it is difficult for the human mind to process. Imagine shrinking Earth down until it's microscopic, only a few nanometers wide, about the size of a virus. At that scale, our entire solar system would be roughly the size of a golf ball, and the Milky Way galaxy itself would span something comparable to the size of North America. Now imagine two golf balls launched toward each other from opposite sides of a continent. The odds of them colliding head-on would be unbelievably small. But galaxies don't contain just two star systems. They contain trillions. So while direct collisions between stars are incredibly rare, they are not impossible. And if another star system passed close enough to ours, the gravitational consequences alone could become catastrophic. A near encounter wouldn't need stars physically crashing together to create destruction. Gravity itself would be enough to destabilize entire planetary systems, distort orbits, and potentially fling worlds out into interstellar space. If, by unimaginable chance, another star system was headed directly toward our own, the experience would be unlike anything humanity had ever witnessed. First signs would appear long before the actual encounter. Astronomers studying the skies with advanced telescopes would notice it first. A distant object behaving differently from the background stars. At first, the changes would seem subtle, but over generations, the approaching system would slowly become brighter. Eventually, people on Earth would begin noticing it with the naked eye. A new star would appear in the night sky, brighter than it should be, stranger than it should be. And unlike the other stars above, it wouldn't remain fixed in place. Year after year, century after century, it would visibly shift against the background of the heavens, slowly moving, slowly growing brighter, its motion becoming impossible to ignore. As the distance closed, concern would turn into fear. The approaching star system would continue intensifying until it dominated the sky itself, brighter than any planet, brighter than any ordinary star, eventually becoming one of the most unmistakable objects humanity had ever seen overhead. And then, the real chaos would begin. The first impacts of the approaching star system wouldn't happen near Earth. They would start far beyond the planets, in one of the most remote regions of our solar system, the Oort cloud. This enormous shell of frozen debris surrounds the solar system at distances so extreme they're difficult to comprehend. Outer boundaries stretch hundreds of billions of kilometers away from the Sun. To put that into perspective, NASA's Voyager 1 spacecraft, traveling at nearly 1 million miles every single day, still won't even reach the Oort cloud for centuries. And once it finally arrives, crossing through it could take tens of thousands of years. That's how vast this region truly is. The Oort cloud is filled with ancient icy objects left over from the birth of the solar system. For billions of years, most of them have drifted silently in darkness, barely disturbed. But an incoming star system would change that instantly. Gravity would tear through the cloud like a wrecking ball, disturbing countless frozen bodies and scattering them in every direction. Massive waves of comets would suddenly begin plunging inward toward the Sun. From Earth, the night sky would transform into something almost unbelievable. Thousands of glowing comets would streak across the heavens. Some would burn brightly in the atmosphere. Others would hang in the sky with enormous luminous tails stretching across entire horizons. For generations, humanity would witness one of the greatest celestial displays ever seen. But behind the beauty, something far more dangerous would already be unfolding. After disrupting the Oort cloud, the approaching system would begin disturbing the Kuiper belt, the vast ring of icy bodies beyond Neptune. Astronomers would detect strange gravitational shifts first. Tiny irregularities in the orbits of dwarf planets, comets, and distant objects would begin appearing across the outer solar system. Then the effects would spread to the planets themselves. Neptune's orbit would begin to drift. Uranus would subtly shift course. Pluto and countless frozen worlds beyond the giant planets would start behaving unpredictably as the gravity of the incoming star system pulled against the delicate balance holding our solar system together. And that balance is extraordinarily fragile. For billions of years, the planets have settled into stable orbital patterns around the Sun. Every world influences every other world through gravity. It's a massive interconnected system, carefully balanced over unimaginable spans of time. Right now, nothing significant from outside the solar system disturbs that arrangement. Space around us is mostly empty, giving our planetary system long-term stability. But a close stellar encounter could unravel all of it. First major disruptions would likely involve Jupiter and Saturn, the two giant worlds whose gravity acts like anchors for the rest of the solar system. If their orbits shifted even slightly, the effects would cascade inward across every planet. Earth would not escape those consequences. As our orbit around the Sun slowly changed, even small deviations could destabilize the Moon. Its orbit might stretch into a more elliptical path. In extreme scenarios, the Moon could even be pulled farther away from Earth or spiral inward toward the planet itself. At first, the changes on Earth wouldn't come as explosions or impacts. They would come through climate. Even tiny changes in Earth's distance from the Sun would dramatically affect global temperatures. Seasons would become unstable. Rainfall patterns would collapse. Agricultural systems would fail. Forests would die. Oceans would shift. Entire ecosystems would struggle to survive. Life on Earth exists within a very narrow environmental range, and humanity depends on conditions that are even more precise. A relatively small orbital disturbance could make large parts of the planet hostile to human civilization within only a few years. And the closer the incoming system moved, the worse the instability would become. As foreign planets and stars entered deeper into our solar system, gravitational forces would intensify. Earth itself would begin experiencing enormous tidal stresses. Powerful earthquakes would erupt across the globe. Volcanic activity could increase dramatically as the planet's crust strained under shifting gravitational forces. Temperatures would swing violently between extremes. Some regions would suffer relentless heat lasting months at a time. Others would plunge into catastrophic freezes, unlike anything in recorded human history. Thousands of years earlier, humanity first noticed a strange bright object appearing in the sky. Now it would dominate it. And if one of those wandering planets passed dangerously close to Earth, the consequences could become almost unimaginable. Even without a direct collision, a near pass by an Earth-sized world would exert colossal gravitational forces on our planet. Earth's orbit could be dragged outward or inward, permanently altering its relationship with the Sun. The stress would become physical. The gravitational pull from the nearby planet would literally distort Earth itself, subtly stretching the shape of the planet as oceans rose and continents strained beneath unimaginable forces. And in the sky above, the approaching world would no longer look like a distant point of light. It would appear enormous, a gigantic planet hanging overhead, growing larger with every passing day, a glowing, multicolored sphere filling the heavens like something torn out of a nightmare. The oceans would no longer behave like oceans. Entire seas would surge back and forth across the planet as gravity violently pulled at Earth from multiple directions. Tidal waves, thousands of meters high, would race across continents, swallowing coastlines whole. The surface of the planet itself would begin to convulse. Beneath your feet, the ground would split apart. Earthquakes, unlike anything in human history, would tear across the globe continuously. Entire cities would collapse in seconds as the crust fractured open. Vast cracks would spread for hundreds of kilometers, consuming everything in their path before slamming shut again with unimaginable force. Volcanoes would erupt everywhere. Jets of molten rock would blast into the atmosphere and rain back down across the planet. Firestorms would spread across continents as the sky glowed red with ash and magma. And all of that would only be the beginning. If a massive planet passed close enough to Earth, its gravity could act like a gigantic slingshot. Instead of merely disturbing our orbit, it could accelerate Earth entirely out of its stable path around the Sun. At first, our orbit would stretch into a long, distorted ellipse. But if the encounter were powerful enough, Earth wouldn't orbit the Sun anymore at all. We would be thrown out of the solar system entirely. Assuming Earth somehow avoided colliding with other destabilized planets during its escape, humanity would begin an irreversible journey into interstellar darkness. The Sun would slowly shrink behind us. Day by day, sunlight would weaken. Within weeks, temperatures across the planet would collapse. Mars might drift past like a fading landmark as Earth accelerated outward into deep space. Soon, the Sun would no longer dominate the sky. It would look like an unusually bright star among countless others. The temperature on Earth would plunge far below anything humans are adapted to survive. Oceans would freeze solid beneath thick layers of ice. The atmosphere itself would begin condensing as the planet lost more and more heat. Earth would become something astronomers call a rogue planet, a world wandering the galaxy with no parent star. It sounds almost poetic. In reality, it would be horrifying. Without sunlight, the only remaining source of heat would come from radioactive decay and geothermal energy deep beneath Earth's crust. The surface would become permanently dark. No sunrise, no sunset, just endless night beneath frozen skies. If humanity had enough warning, some people might survive underground. Massive insulated habitats powered by nuclear reactors could provide artificial heat, food, and light. Entire civilizations might retreat beneath the surface in an attempt to outlast the cold. But life would never resemble the world we know today. The survivors would exist on a frozen, wandering planet, isolated from every star, drifting through interstellar darkness for millions, perhaps billions of years. But even that scenario is not the worst possibility, because there is something far more catastrophic than a close flyby: a direct collision. If another Earth-sized world were actually on a collision course with our planet, the sight in the sky would become unbearable. The approaching planet would grow larger every day until it filled enormous portions of the heavens. The oceans would rise into colossal tides capable of erasing entire coastal regions. Earthquakes would rip continents apart. Volcanoes would erupt simultaneously around the globe as gravitational forces stretched and distorted Earth's crust. Then the incoming planet would dominate the sky completely, and at that point, there would be no escape. As the two worlds approached one another, their gravitational fields would begin tearing material away from both planets. Atmospheres would stretch into space. Rivers of glowing gas and debris would stream between the worlds. Long before impact, the surface of Earth would already be unsurvivable. But if you could somehow witness the collision itself, it would be one of the most violent events imaginable. When the two planets finally slammed together, the energy released would exceed billions upon billions of nuclear explosions, occurring simultaneously. And remember, these are not stationary objects. Entire planets are moving through space at extraordinary speeds. This would not resemble a car crash. It would be more like two mountains hurled at each other at hundreds of thousands of kilometers per hour. The heat generated would instantly melt and vaporize enormous portions of both worlds. Oceans, continents, atmospheres. Everything would be transformed into an expanding cloud of superheated rock and gas. For a time, there would no longer be an Earth, only a glowing inferno suspended in space. Eventually, gravity would begin pulling the debris back together. Molten material would collide, merge, and slowly form an entirely new planetary body. Ironically, scientists believe something similar may have happened billions of years ago when a Mars-sized object collided with the young Earth, ejecting material that later formed the Moon. But in this case, humanity would not survive to witness the aftermath. Of course, planets are not the only danger during a galactic merger. A passing star itself could devastate the solar system with radiation and gravity alone. And beyond all of that lies something even more terrifying. At the center of the Andromeda galaxy sits a supermassive black hole containing the mass of more than 100 million suns. Our solar system ever wandered too close to such an object, there would be no dramatic escape, no second chances. We would simply disappear into the darkness. Thankfully, scenarios like these are extraordinarily unlikely. Despite the terrifying possibilities, the most probable outcome is actually far less destructive. The distances between stars are so vast that our solar system will likely pass through the galactic merger without ever encountering another star system at dangerous range. In all likelihood, the Milky Way and Andromeda will slowly merge over billions of years, while the solar system quietly settles into a new orbit around the combined galaxy. From Earth, the night sky would gradually transform. The familiar spiral shapes of both galaxies would distort and dissolve into one enormous tangled structure. A future galaxy some astronomers have nicknamed Milkdromeda. The constellations humanity has known for thousands of years would disappear completely. New rivers of stars would spread across the sky. Dense clusters, glowing clouds, and brilliant bands of light would shine far brighter than our current night skies. And somehow, after all the chaos, Earth may still survive to witness it. Not bad for a planet currently racing through the galaxy at 720,000 kilometers per hour without anyone noticing. But galaxy collisions aren't the only terrifying events waiting out there in the cosmos. Because if two galaxies colliding sounds extreme, imagine what happens when two black holes collide.